Organic chemistry, my most favourite topic. I'm going to limit myself to 30 seconds for each slide, and I'm going to try and tell you some really important things that we need to know to pass this standard in our exam. Look, feel free to watch this a few times and take down notes if you need to, but look, just see if you can try and get the most important points that I'm trying to get across here. Right, first group of organic compounds we're going to look at, the alkanes. Alkanes just have carbons and hydrogens. Notice here we've named two alkanes. The two here refers to the carbon, the number of the carbon that the methyl group is coming off, and the last bit refers to the name ane, refers to whether it's an alkane. One at the bottom, 2, 3, don't forget the dimethylpentane. Really important, okay, common mistake, don't do it. Okay, onto the alkenes. Notice all alkenes have got a double bond. Pent-2-ene, double bond coming off the second carbon. Propene, it's coming off the first carbon, but we don't need to put the one in because it can only ever come off the first carbon. Hex-3-ene, it's coming off the third carbon, so it's got the 3 there. Remember, we can also have cis and trans for some of these, and you have to be on the lookout for those. But we'll look at the geometric isomers later. Alcohols. Right, recognise these babies. They've got an OH sticking out of them. You just look round any molecule. If you see that OH, you know it's an alcohol. It's going to end in an ol. Okay, we can remember we number from whatever side is going to give us the smallest number. The first one there, pent-2-ol, because it's coming off the second carbon from the right-hand side. We've got hex-3-ol and ethane-2-ol. Alcohols. We'll learn some more about the properties later as well. Okay, going on from alcohols, we've got haloalkanes or alkyl halides. Now they can either have chlorines, bromines, fluorines. They've got the prefixes chloro, bromo, fluoro. And the name, just in a similar way to alcohols, the end of the name is always ane, and we've got either the chloro, the bromo, or the fluoro. Notice there for the first name that we've got both 2 methyl and 2 chloros in the naming. If you've got both there and they're different numbers, the alkane, the halogen, takes preference. Carboxylic acids. Right, carboxylic acids, these you have to make sure when you look at compounds, if you see an OH, check to see if there's a carbon next to it. If there's a carbon next to it with a double bond O, carboxylic acid. Carboxylic acid, we'll look at the properties later, but we always number any groups that's coming off them from, we start numbering from the end that has the carbon double bond OH. Okay, so the last one there, 4-chlorobutanoic acid. Esters, similar to carboxylic acids, but you'll notice that the OC double bond O is always in the middle of a molecule. Okay, now we've got two sides to it. The naming is really important here. We've got the side with the carbon double bond and the side without the carbon double bond. The side with the carbon double bond is always O8, like pentanoate, and the other side is always ol, like methyl pentanoate. The next one, ethyl propanoate. Alkynes. Okay, alkynes, we just need to know how to name these. If you see a triple bond, okay, strange sort of looking bond, that's an alkyne. Named the same way as alkenes, apart from it's got YNE on there. Ine. Pent-1-ine here, and then we've got but-2-ine. Yeah, haven't got much more to say about them. Hey, one thing about them, they can also have things added to them because they are unsaturated. Okay, alkenes. Now, addition reactions is what alkenes do the best. And the reason they do that, if we look at these two pictures I've drawn here, the first one, there's the double bond. If we break one of those bonds, you notice we've got 2 spots, one on the other side where the double bond was, that I'll put a wee dot beside. That's where the new thing's going to join. And it's only going to join where the double bond was. Okay, so what we're going to do now is we're going to look at a few examples of that, but think back to that. They're always going to join with double bond breaks. Okay, so first one here, we've got hydrogen adding to the carbons of the double bond. So we need a nickel catalyst, so it's sitting on top. Second one, we're adding water. We need to add to that, we've got H2SO4, and we get an H added to one side and OH to the other. Always the carbons of the double bond. Last one, we're adding 2 bromines or halogens. They always add to the carbons that were the double bond, and you see there what we've got. Okay, going on. we've got Markovnikov's rule. Okay, really important. The rich get richer. So what we're looking at here, the light blue one has 2 hydrogens joined to it. The dark blue one has 1. The light blue carbon here is the rich one. So it's going to get an extra hydrogen and get richer. That is our major product in this reaction. Most of our reaction will make that one, and some of the other product will be formed. Okay, so we've got a major and minor. It's not always 80 and 20%, it could be 60, 40, 70, 30. Okay, still with addition, because these alkenes love addition, we've got polymerization, right? Where we take lots of little individual bits and they add next to each other and make big long chains. Look at this one here, propene. See where it breaks at each carbon, so it's got a join at each carbon. That leaves that wee dangly bit, that wee CH3 hanging off the bottom. Take real care with that. A lot of questions that they'll give in the exam will have it, so you have to join it and have a dangly bit coming off. Okay, elimination here. So these types of reactions, we're looking at alcohols, alcohol reactions, elimination. We add concentrated sulfuric acid that loves to take water away from things. It takes a hydrogen and oxygen away, and once those are removed, those broken bits join back together and make a double bond, an alkene. Oxidation, notice the alcohol part of it, when we add dichromate, acidified dichromate, the first one turns into carboxylic acid, or we add permanganate, same thing happens, turns into carboxylic acid. Esterification, right, esterification. This is when we have a carboxylic acid, the one on the left, and an alcohol. We're adding concentrated sulfuric acid again. It loves water. It's going to rip water off, an OH off one and an H off the other. And I think I've got one of those lines in the wrong place. And it joins them back together. Notice if you've got a question that was made from 2 different things, it's always going to be esterification, because that's the only type of reaction we have that's made from 2 different organic products. Carboxylic acids always undergo what are called acid reactions. Now the first one is a weak acid, so it reacts with water, and that means it's going to dissociate. It's going to dissociate in water. The second one is it's going to react with a metal. It's going to react with sodium hydroxide, I think I've got there, and it's going to react with a carbonate. Right, going on to the next part here, we've got hydrolysis of ester. Okay, this is when we add weak acid or weak base, and it splits the ester back open again. Now, we always split the ester between the carbon and the oxygen here. We've got the anorate side that makes the carboxylic acid, and we've got the other side that makes the alcohol. Notice if we add OH there, the second reaction, we don't actually make a carboxylic acid, we make the ion of the carboxylic acid. Okay, that's quite important. They might ask you about that. Okay, next bit, structural isomers. Structural isomers, we've got 2 here, and when we look at them, we see we've got 4 carbons, we've got 10 hydrogens, but they're joined in different ways. So we've got exactly the same atoms, they're joined in different ways, structural isomers. You can draw, so one thing you notice about structural isomers, if they are true structural isomers, they will have exactly the same atoms, but they will end up with different names. Okay. Different to that, geometric isomers. The geometric isomers have exactly the same atoms. They are joined to the same atoms, but spatially they are different. So notice for this, these 2 here, with the first one we've got the chlorine, one on the top, one on the bottom, across from each other. That's called a trans. So we put that in front. And the second one, they're still bonded to the same carbons, but they've got both chlorines at the top. And that one there is a cis. Okay, so these are geometric isomers. Okay, tests to identify for organic compounds. Really important. They're going to ask you about this type of stuff. They're going to ask you to come up with a scheme, come up with a plan to test and find out which things are which. So you've really got to know all of these tests. Okay, first one, alkanes, alkenes, even if they had an alkyne. Okay, if you put those babies, if you put them in water, they're going to float on top. You're going to get water, and then you're going to get these things sitting on top. They are insoluble. They don't dissolve. Okay, so you know that they're not. You know that could be those. Okay, if you want to be sure that it's an alkene and not an alkane, you add bromine water. Bromine adds to the double bond, and basically the brown coloured bromine or the orange coloured bromine disappears. It becomes colourless. Another reaction that they sometimes use is permanganate. If you add permanganate to the alkene, it makes something called a diol, an alcohol with 2 alcohol groups, and the colour goes from purple to brown. Okay, purple to brown. So we've got bromine water, orange colourless, permanganate purple to brown. Alcohols. Okay, identifying these. First things, they dissolve in water. Okay, there's only a couple of these compounds that dissolve in water. Second thing, they have a neutral pH, pH of 7. These are both physical tests. Okay, take care, sometimes ask you for physical tests, sometimes ask for chemical tests. Chemical tests for these are if you can oxidize them. So if you add acidified dichromate, it goes from orange to green. Okay, that's Cr2O72 minus. Permanganate goes from purple to colourless. Carboxylic acids. Carboxylic acids, the second one that dissolve in water. There's only two that dissolve in water, carboxylic acids and alcohols. They have a sharp smell, remember that. They have a pH between 3 and 5. These are physical tests, the first few. They usually want you to tell them about chemical tests. So the chemical test, if you take a carboxylic acid and you can react it with a base, a carbonate or a metal. Specifically, they're usually asking for sodium carbonate or calcium carbonate, and it gives bubbles, carbon dioxide bubbles. That's the test, and that will show you've got an acid. Esters. Okay, you can't really do a test to confirm you have an ester, but it might be the one left over. Now, an ester will not dissolve in water. Okay, so, and the other thing is it has a fruity smell. Okay, so it's going to have a pleasant fruity smell. So you might be able to distinguish that between that and an alkane. Okay, classifying. Most of us are pretty good at this. Remember, we've got primary, secondary, tertiary. We use it for alcohols and alkyl halides. If your group is attached to a carbon that's only attached to one other carbon, it's primary. If that carbon that the group's attached to is attached to two other carbons, it's secondary. If it's attached to... Right, triglycerides. These are called fats, okay? They're really just a giant ester or triester made of 3 esters. Look at there, we've got that glycerol. It's an alcohol with 3 OH groups, and we've got 3 carboxylic acids that will join together in an esterification reaction and make our fat, a triester or triglyceride. Notice, if you can do that, you can also do the opposite. You can hydrolyze a triester. Right, that's me done. Look, go over this a couple of times, try and pick up all those little bits of information, try and remember all that knowledge, make some notes. All those little bits I've said on here, or the little bits you can see, are really important. Make sure that you concentrate on them. Make sure you go back again and start it again. Any other questions, just bring them in, come and see me sometime. I'm more than happy to help. Okay, also let me know if any of this was helpful, because I can redo it and make it a bit better, or maybe do some for some of the other topics. Thanks.